Solutions to Factored Form Part 2. In this video, you'll learn how to explain how the numbers and signs in a quadratic expression in factored form relate to the numbers and signs in an equivalent expression in standard form. So if we have a quadratic equation in factored form, like x plus m times x plus n, then we can create an equivalent expression in standard form as x squared plus m plus nx plus m times n. We can also determine the sign of the factors by looking at the constant. If the constant is positive, then both factors are either negative or they're both positive. If the constant is negative, then one factor is negative and one factor is positive. So we'll keep this in mind as we look at some examples. We'll complete the table so that each row has an equivalent expression. Here's our first table, where two expressions are in factored form and two expressions are in standard form. Let's start by taking our factored form of x plus 5 times x plus 6 and turning it into standard form. Our first term is x squared, and then our second term will be found by adding both of our constants together. So this will give us 11x, and then our last term will be given by multiplying our factors. So this will give us 30. Now we have this factored form in standard form as well. Now we'll look at the standard form of x squared plus 13x plus 30 to put it in factored form. We'll start by listing our factors of 30 and then find which pair will add to 13. We can see that the pair of 10 and 3 will multiply to 30 and add to 13 like we needed to. So in factored form, we'll write x plus 10 times x plus 3. Now let's look at the one below it. Our first term will be x squared, and then our next term will be found by adding negative 3 and negative 6 together, which gives us negative 9x. And now to find the last term, we'll multiply our factors, which gives us positive 18. Now let's look at our last example. So we'll write down the factors of 18 and see which one will give us negative 11. We can see that negative 9 and negative 2 will add to the negative 11 that we need. So we'll put these factors in for factored form. Now if we look at the constant term and all of the equations that were in standard form, we can see that they're all positive. And this makes sense because all of those expressions in factored form had the same pair. They were either both positive or both negative. Here's our next table. So we'll start with our first expression of x plus 12 times x minus 3, and we'll put it in standard form. Our first expression will be x squared, and then our second term we'll find by adding 12 and negative 3, which gives us positive 9x. And then our last term we'll get by multiplying our factors, which gives us negative 36. Now we're going to turn the rest of the expressions in standard form into factored form. So we'll start by making our list of factors of negative 36 and find which one adds to negative 9. We can see that 3 and negative 12 will be the pair that satisfies this. So we'll put those numbers into our factored form. Now let's look at the one below it. So we have the same factors of negative 36, but this time it needs to add to negative 35. We can see this happens when x is 1 and negative 36. So we'll put this into our factored form. Now the next one is almost identical to the one we just did, except for 35 is now positive. So this time we'll just make sure that 1 is negative and 36 will be positive, since when we add these together, we'll get the 35 that we needed. In this example, we're going to find two numbers that would satisfy each requirement. Our first one says to multiply to negative 40 and add to negative 6. So we'll list our factors of negative 40 and see which ones add to negative 6. We can see this happens when x is 4 and negative 10. Our next one says to multiply to negative 40 and add to positive 6. So we'll have the same factors, but this time we'll use negative 4 and positive 10 to get the positive 6 that we want. Now we want to multiply to negative 36 and add to 9. So we'll list our factors of negative 36, and we can see that negative 3 and 12 will give us the 9 that we want when we add them. And the one below it says to multiply to negative 36 and add to negative 5. So we'll have the same factors, but this time we'll use positive 4 and negative 9, since this will add to the negative 5 that we want. In this example, we're going to use the diagram to show that x minus 5 times x plus 8 is equivalent to x squared plus 3x minus 40. So we'll start by expanding our grid. Multiplying x times x will give us x squared. Now we'll go below and multiply x times negative 5, which gives us negative 5x. We'll jump back up to multiply 8 times x, giving us 8x, and then our final box we'll find by multiplying negative 5 and 8, which gives us negative 40. If we add all of these terms together and combine the like terms of 8x and negative 5x, we'll get x squared plus 3x minus 40, which is equivalent to the expression they gave us, so this is equivalent. In our last example, we're going to write each equation in standard form into factored form. So we'll look at our first expression of x squared minus 2x minus 35. So we need two numbers that multiply to negative 35 but add to negative 2. Those two numbers would be negative 7 and positive 5. Now let's look at the one to the right of it, x squared plus 2x minus 35. So we need two numbers that still multiply to negative 35, but we want them to add to 2. So we'll use the same factors, but now 7 will be positive and 5 will be negative so that we get positive 2. Now let's look at the one below on the left. So we have x squared plus 12x plus 35. So we still need two numbers that multiply to 35, but we want the middle term to add to 12. So we'll keep the same factors, but we'll make both of them positive since our middle term is positive 12. And now we have our last example. The only difference between this one and the one we just did is that 12 is now negative. So we'll just make both of our signs negative, so when we add them, we get negative 12, but we still get positive 35 when we multiply them. Now let's summarize what we've learned. Multiplying two positive or two negative numbers results in a positive product. And multiplying a positive and negative number results in a negative product. To write an expression in factored form when given in standard form, we need to find two numbers that add to b and multiply to c.